right? So we're going to do a couple more examples here. If any of you have had some calculus before, this one looks a little familiar, right? Both of these examples I think that I was going to do in this video do actually come from difference quotients. If you don't really know what that is, doesn't matter. You'll know tomorrow. Well, not tomorrow, next week. Okay, so again, if I put in 0, clearly I have 0 in the bottom, but I also have 0 in the top because I have 25 minus 25, right? Now, the problem is, of course, it's really easy to see in this case what I want to do because the bottom is just h. So I want to factor out an h from the top. That's my goal because then the h's cancel out. But the problem is, all right, I can't factor that yet, so I just have to do a little bit of work here, right? I have to work that out. So this is 25 minus 2 times, right, I almost wrote 50. 2 times 5 times h, so 10h, right, plus, so the plus there, right, plus h squared, and then minus 25. Well, that's good, right? Now, my next, I can see the constant is canceled out, so I can pull an h out from the top, easy peasy, right? This guy goes to that, and the h's cancel out. Once the h's cancel out, I end up with something very simple, right? And now all I have to do is let h go to 0. Now I can, here, until I cancel out these h's, I can't put in 0 because I'll still get 0 over 0. So you can kind of, in your mind, you could try putting in 0 wherever you want, but until you cancel out that value of h, it's not gonna do you any good. Once you cancel out the value of h, though, everything works out nicely. Now 0 is in the domain. All I have to do is set h to 0, so my answer is 10. Okay? So let me do another one, which is somewhat similar, but takes a little bit of a different kind of trick. I'm going to do one with a square root. Okay, now, it's a square root now instead of a square. Fine. I want you guys to know, let me ask you, what would happen if I did this? Well, I would never do this because this is wrong, right? But oftentimes students make this mistake with square roots. First of all, you can't do this. So don't do this because I'll fail you. If I have square root of a plus b, this is not the square root of a plus the square root of b. Okay? It does not distribute. In fact, there's some other stuff in there. It's not that. So you can't break it up like that. So you can't do that. So the question becomes, again, I have this situation. Yeah, so this is definitely not true. Don't do this. It's awful. Please don't do this. Yikes. Yikes. Yikes, yikes. Okay. The question becomes, what do I do with this? Because I can't break that guy up. So it's this kind of similar to the last example where I got this t in the bottom that's going to 0, so I want to cancel out the t. But if I can't break this guy up, it's not going to be clear what's going on. So there's a trick for these. It doesn't seem, okay, you'll see by the end why you would do it, but at first it seems kind of weird. You guys are used to rationalizing the denominator. In some sense, what we're going to do here is exactly rationalizing the numerator. We're going to multiply both top and bottom by the conjugate, I would say conjugate radical. Is that the right thing? This guy, this whole thing, but with a plus. Okay, so this is our trick for this kind of problem. And we will see quite a few of these in our lives here in Calculus 1. So this is a good trick to have in your back pocket. Okay, what we're really doing here, first of all, so know that this is a trick that you have to know. But we also need to know why it is helpful or why it works. You can always multiply by 1. This is a special form of 1. And we're picking it because it'll make the top work out. But you always have to multiply by 1. You can't just multiply by this. You have to have the same thing in the bottom too. So don't forget your bottom. That's an easy thing to do. A lot of people make that silly mistake too. The silly mistake I had on the board here, or another silly mistake, is that you know you were going to multiply by the conjugate radical, but you forget to multiply the bottom by the conjugate radical as well. You can't just multiply by stuff, unless that stuff happens to be equal to 1. If the stuff happens to be equal to 1, you're good to go. So here's the situation. Why did I do this? Okay, I did this because what I'm going to try to use is I want to get rid of that square root so that I can cancel out those t's. But I can't get rid of the square root just by this, but this thing allows me to get rid of the square root, because what you're really doing is, look at this, this is like some a minus b, and then I'm multiplying it by some other a plus b. So what do I get? The cross terms cancel out. I end up with a squared minus b squared. Okay? I can write this out explicitly, and I will write it out explicitly in the next line just so that you've seen it. But you don't need to write it out explicitly since you're using this property. You can just go ahead and end with that. Okay, so I'll show you in a second. But just to convince you or to remind you as to why this trick works, I am going to go through the writing this out explicitly. Okay, so I'm foiling the top, right? So I have that times that. I've got the square root of t squared plus 4 squared. So what is it? Foil, right? First, outer, inner, whatever. You just have to multiply everything by everything else. So the outers is this. The inners is this. And the last is a minus 2 times 2. Okay, so that's my top. I know, don't want to forget my bottom. So my bottom is this. And you can mess with the bottom if you want, but I wouldn't. Because my goal is to get rid of this guy, right? I want to cancel out that t. If I start putting him in there, then I'm going to have to take him out again. I'm wasting my time. So I don't do it. I just leave it, right? Because otherwise it's a waste of time. All right, so let's see what this is now. Limit as t goes to 0. On my top, this is the square of the square root, so this is t squared plus 4. These two cancel out, and then I've got a minus 4 here. Okay? And then the bottom just stays the bottom. Okay? Now, you can see, as I said, sometimes it's nice to write it out to make sure that you did it right, that you multiplied by the right thing. If you want to go directly to here, I will absolutely accept that because you're just using the a minus b times a plus b business. So you don't have to write it out if you don't want to, but not a bad idea to write it out if you do want to. Okay, so here we have this. Huh. I don't know where is t squared. Okay, whatever. That'll be fine. Okay, so then what do I end up with? I don't know if it wasn't supposed to be t squared. I think it was just supposed to be t if this was, it's not the difference quotient if this was a difference quotient, but that's fine. It's still a limit. We can do a limit. Plenty of limits in my life to do. This is t squared here. Okay, so now I can cancel out this guy, that guy. T in the top, square root of t squared plus 4 plus 2. Now what's going to happen when I put in t equals 0? Well, the top is still going to go to 0, right? And that's fine. It happens. Sometimes the answer is 0. But look at the bottom is no longer 0, right? Because it's a plus, whereas back, whatever, it was 0 here because we started with a t, right? Okay, but now this bottom is no longer 0. The bottom is square root of 4 plus 2. Okay, so the bottom is 4. So 0 over 4, it's just 0. So my answer is 0 in this case, which is fine. You can have an answer that's 0.